Hello everyone, welcome back to my channel. Today we are going to discuss stability and transient response characteristics in control engineering. I will introduce the following function in MATLAB: pole, isstable, and stepinfo. First, let's build transfer function p equals tf. The coefficient of numerator is 1, 10. And the coefficients of denominator is 1, 2, 3, 10. Let's use pole function to calculate transfer function p. Run it. Since the denominator of this transfer function is a third degree polynomial, so there are 3 pole solutions. And the real part of the solution is positive. So we can determine that this system is unstable. Let's see the curve of the transfer function. The set time t equals 0, 0.001 to 10 seconds. Then figure 1. Build a figure of this window. Then step transfer function p and time. Let's see the curve. Run it. Here's the result. Obviously, it doesn't converge and is unstable. Alright, let's see another example. Comment this transfer function p and build a new one, tf. The coefficients of numerator is 1, 3, 2. And coefficients of denominator is 1, 4, 11, 14, 10. This is a fourth degree polynomial, so there should be 4 pole solutions. Comment this code. Let's see the result of the pole value. Alright, this is the transfer function. And this is the result. There are 4 solutions. And the real part of the solution is negative. So we can determine that this transfer function should be stable and converge. Let's see the curve. Alright. Obviously, it eventually goes to stable and converge. From these 2 examples, we can draw an important conclusion in control engineering. If the real parts of a transfer function's poles are negative, the system is stable. Otherwise, it's unstable. We can also use the isstable function to determine this. If the logic value of the isstable is 0, it indicates instability. If it is 1, it indicates stability. First, let's use the unstable transfer function p. So the isstable p. The answer logical goes to 0. It indicates instability. And comment it. Use the second transfer function. This is the stability. Okay, the logical is 1. So it indicates stability. Alright, next is the step response characteristics. In MATLAB, first we build the transfer function p. And we only use stepinfo. This function, we can calculate the characteristics of step response. Run it. Here's the result. As you can see, for this transfer function, the rise time, transition time, due to the peak time, there are a lot of characteristics. I will use this picture to explain all the details. First, the ultimate goal of our system is the steady state value, 1.0, represented here as y infinity. For this system, it stabilizes at 1.0. Everything else we measure is basically comparing this curve to this target line. Look at this. Starting at time 0, you will notice the undershoot is 0. This means our system immediately starts moving in the right direction towards target without any inertia negative dip. So, how fast does it get off the starting line? This is rise time, TR. MATLAB calculates this at the time it takes to go from 10% to 90% of y infinity. Here, it takes around 0.4 seconds. But because it's moving fast, it overshoots the target. It hits a maximum peak value of 1.35. The time it takes to reach this exact summit is our peak time, TP. Here, this time, around 1.05 seconds. Because our target was 1.0 and we hit 1.35, the vertical difference gives us our overshoot percentage. As you can see from the red arrow, this system overshoots its goal by a massive 35%. After that massive peak, the system oscillates. MATLAB tracks the highest and the lowest points during its bouncing phase using settling max and settling mini, which is the lowest value after crossing the steady state line at around 0.8772. Finally, we want to know when the system has practically came down. We create a 2% error bound around our target of 1.0. The exact moment the curve enters this green band and never leaves it again is our settling time TS. This time. Alright, that's it. We just use a simple stepinfo command. You get a complete physical profile of your system's speed, stability, and accuracy. Feel free to pause the video and take a screenshot of this diagram for your own notes. See you next time.